Well, let us analyze this another feedback network, which is represented by a two-port network, and we want to identify whether this is a current amplifier, a voltage amplifier, or trans-resistance amplifier, or trans-impedance amplifier. In fact, the trans-resistance and trans-impedance are the same. Or finally, transconductance amplifier. So out of 4 classes that we have seen in our previous model, I challenge you to identify what kind of amplifier this is and what kind of feedback it utilizes. We've also seen there are 4 types of feedback, and we are going to see that one by one. So let us step by step analyze this two-port network. This is the input side, or this is the output side, or input port and the output port. So at the input port, you apply an external voltage source Vs as shown here, and then you have a forward gain block, which is producing an output current. Therefore, the gain of this block is called as A equals to output divided by input, which is the output current divided by input voltage. Okay, so input voltage is V in. We'll see how the V is becoming V in a moment. So we see that if we just neglect this feedback for a moment, and we just see that there is a straightforward path from input to output, then this amplifier is called as transconductance amplifier, because it gives you the ratio of output current divided by the input voltage. That's the transconductance. Now, the output current becomes a current flowing through the load, that is IL, and here is your load and through which the current IL flows. So what you are basically sensing is the output current IL that becomes an input to your feedback circuit, which is represented by this box. So the input to this feedback circuit is the output current, which is I out, and the output of the feedback circuit is the voltage, which is called as feedback voltage VF, which is the product of beta multiplied by the input, the gain times input. Output is equal to gain times input, or beta is the output voltage divided by the input current. So in fact, this is reflecting resistance. So your feedback circuit is resistive, or you can say the feedback circuit is, the gain of the feedback circuit is the resistance. Okay, and the produced voltage, now look at the polarity here, is getting mixed up with the input signal source Vi. Usually if it is a negative feedback, so the positive and the negative that appears here, which is the Vn, is then the difference between the input source voltage and the feedback voltage Vs minus Vf in case of negative feedback. Okay, so and then again this error voltage, the difference voltage between the two, is being given to the amplifier, which is the transconductance amplifier. Okay, so the feedback is the circuit is also called as current series circuit. This circuit is also called as current series feedback. In fact, let me write it: current series feedback, because this indicates what you are sensing. You are sensing the current, and this indicate in what fashion you are adding to the input. So you are adding the voltage in series with the input. So this is called as, in other word, you can say that I am sensing the current. So it's called as shunt series feedback or shunt series amplifier configuration or shunt series feedback amplifier. Okay, so hope you understood the basics of this network. So there are four types of feedback series, four types of feedback amplifiers, series, series shunt, shunt series, and shunt. So I encourage you, we have got one here. I encourage you to draw the block diagram for the remaining three. Okay, so stay tuned for more engaging contents like this for a basics and share it for a wider reach. Wish you happy learning.